Mathematical methods of physics, error analysis in and uncertainties. So here we have measured values. Measured values means for a random experiment you have measured some values, that is called measured value. Okay. Yeah. For example, you have taken some x1, x2, x3. These are your measured values. Okay, etc. up to xn. These are trials. For the first trial you got x1, second trial x2, etc. Now there will be some true value for a particular quantity. For example, if you are measuring the length of some scale, okay, or a wire, you may there may be a accurate value, that is nothing but, for example, 3.54. then this particular value is called the true value or the average value. True value, average, mean value. Okay. Now then, what is the absolute error? Absolute error. Okay, before going to absolute error, let us give an formula for the average value. It is nothing but it is represented by xm, indicating the mean, or sometimes it will be represented by x bar, indicating the mean value. Then you have x1 plus x2 plus x3 etc. up to xn divided by the number of trials. This is the average value. Now coming to the absolute error, it is represented by delta x1. That means the error that has occurred in the first value. That delta x1 is equal to mod of x1 minus the mean value. Okay. And what is delta x2? Delta x2 is x2 minus xn, and it goes on. Okay. Then you will have series of delta x1, delta x2 etc. up to delta xn. Now these are absolute errors. Fine. Yes. Yeah. Now coming to the mean absolute error. Mean absolute error means we had the absolute error as delta x1, delta x2, delta x3 and so on, delta up to delta xn. Mean absolute error means if there are n number of trials, here you have n trials. Mean means nothing but delta x1 plus delta x2 etc. up to delta xn by the number of trials. Fine. Now coming to relative absolute error. What do you mean by relative absolute error? So relative absolute error means the mean absolute error, that is delta xi divided by xm. Sorry, here xm. So this is delta xm. Fine. This value is called mean absolute error. Delta xm is mean absolute error, and the relative absolute error is nothing but delta xm divided by xm. Now here comes the relative percentage relative error. That is nothing but the relative absolute error multiplied by 100, that is delta xm by xm, that is the mean value, times 100. This will be in terms of percentage. Now we have few rules for finding the error in different quantities that are either multiplied or added, something like that, depending on the mathematical operation. Now z is equal to plus or minus iy. Now one, you have to remember that the error will always get added up no matter what. Okay, just keep adding on. Adding means not the operation adds, it is increasing always. Okay, so for z is equal to delta x, x plus or minus y, we can write delta z, that is the error in z value is nothing but error in x plus error in y. There is no plus or minus, please remember, it is error in x plus error in y. Okay, now for the product rule, what is delta x? Okay, before that, yesterday we have seen how to differentiate. Let us try differentiating this. Dz is equal to, first let us take x as constant, x times dy, plus now let us take y as constant, y times dx, right? Dz is equal to x dy plus y dx. Now let us divide it by z. Now what is z equal to? Z is equal to xy. Then we can write it as x dy divided by x dy divided by xy plus y dx divided by xy. Now we can just simplify this, remove whatever is common. So dy by y plus dx by x, this is nothing but dz by z, right? But we want dz. What you have to do, you have to just multiply this constant by not constant, this value by z. This is how you can find out. Now similarly, for if z is equal to x by y, delta z by z is equal to delta x by x plus delta y by y. If they are asking the percentage, just multiply by 100. Okay, here also this is same. Instead of d, just put delta z by z. D is nothing but small change in z, or error, percentage error in z. Now coming to the exponential rule, you have z is equal to x to the power n. What you can do is, it is n to the power, so delta z by z is given by n times delta x by x. Okay, n times delta x by x. Combination rules. Combination rule, let us take one example. Let us write omega is equal to x to the power a, y to the power b, and z to the power c. Sum omega is equal to x to the power a, y to the power b, z to the power c. Now delta omega by omega is equal to, how to write this, a times delta x by x plus b times delta y by y plus c times delta z by c. Okay, so this is how you can write the combination. Now suppose I give you another formula. Simple pendulum, time period t is given by 2 pi under root L by G. Now how will you write the percentage error in delta t time period? So delta t by t is equal to, this is L to the power half and this is G to the power minus half, but you need not worry about the minus. What is it is addition. So half times delta L by L plus half times delta G by G. Okay, now for example you have volume of a sphere that is equal to V is equal to 4 by 3 pi r cube. So what is delta V by V is equal to, all these are constant. See, there is no error in constants. Okay, so that will be equal to 3 times delta R by R, right? Similarly in let us take the force of two charged particle K Q1 Q2 by R square. Now how can we write? K is a constant, so we can leave that. So error in Q1 by Q1 plus error in Q2, that is change Q2 by Q2 plus, and here it is R square, so this is 2 times delta R by R. So this is nothing but the relative error in force. All these are relative errors. Okay, this also, this also. Relative error means with respect to the mean value or the original value. Now here you have a question. Time period of simple pendulum is given by t equal to 2 pi under root L by G. If the maximum error in measuring t time period is 0.5% and length L is 0.5, the other is 0.05, find the maximum error in measuring G. Now how to go forward with this question? First thing that you have to do is write G in terms of the other quantities which are being given. For example, t is equal to 2 pi under root L by G. Now what you have to do is you make the t square is equal to 4 pi square L by G. Now bring this G to the left, make it the subject. G is equal to 4 pi square L by t square. Okay, now that's given by delta G by G is equal to, this is constant, so delta L by L plus delta T 2 times by T. Now it is given in terms of percentage, so multiply by 100. So this also we can write it as percentage, percentage, percentage. That means just multiply by 100. Okay, so this is what you want. That's equal to delta L by L percentage, that is percentage is given as 0.5 plus 2 times delta T by T, what is given as 0.05. So 2 times 0.05. Now this constitutes 0.5 plus 0.1, which is equal to 0.6%. So your option is B. Uncertainties or RMS errors. See, RMS error is given by this is what is RMS, root mean square error. Okay, that is simply nothing but our standard deviation. Both are same. It is said uncertainty in delta x. We have seen uncertainty is in delta x, delta px, that means in position and momentum. Similarly, in any quantity, the uncertainty delta x is given by under root 1 divided by n sum over I xi minus x bar whole square, where xi is the one of the values that you have got, random values. This is the average value, x bar whole square. Okay. Yeah. Now this is also called, the uncertainty is also called, it is the RMS value of RMS deviation. This is the deviation, RMS deviation of any physical quantity, any physical quantity. Here what is the physical quantity? Position delta x quantity from its mean value, from its mean. What is the mean here? X bar. In quantum mechanics we write like this. In quantum mechanics we have delta x bar. This is the operator x. It's equal to under root this represent the average value, x minus expectation. This is expectation. Okay, expectation x square, sorry, expectation x whole square. Now 2 here, this is 2 here. All right. Yeah, delta x is equal to under root expectation x minus expectation x whole square. Okay, fine. Now if you are asked delta x square, delta x square is nothing but the variance. Variance is nothing but this standard deviation has a symbol, that is sigma. Okay, sigma variance is equal to sigma squared. Sigma square. Okay, fine. These are variance sigma. Fine. That. Yes. Now here some rule. Just like in our answered the errors, here also we have some rule. What? Let us see what are they one by one. Z is equal to x plus y, and here what we do is delta z whole square, just finding the error and its square, delta x whole square plus delta y whole square. Now this is uncertainty is not equal to delta x plus delta y as we have done earlier. Now this is yeah, this is the difference between the error and the uncertainty values. Okay, yeah, fine. Now what you can write, delta z is equal to under root delta x whole square plus delta y whole square. One thing here to be noted, just a note, uncertainty in any measurement cannot be added. Uncertainty in any measurement cannot be added. So, but what you can add is square of the uncertainty can be added. Square of uncertainty can be added. which means your there is standard deviation and sigma, right? Sorry, standard deviation and variance. Standard deviation is a root value, root of something. Variance is the square of the standard deviation. So here you cannot add. Addition is not possible. Addition is not possible. You cannot add the standard deviations, but variance you can add. Okay. Now another result or note. This is first one. This is the second one. Some result, that is the net uncertainty. Net uncertainty is always greater than uncertainties of individual uncertainties of individual quantities or independent parameter. That means if you consider delta z square is equal to delta x whole square plus delta y whole square, what you can infer from this, if you can draw some triangle, right angled triangle, where this is your delta z and this is your delta x and this is delta y. This is delta x square plus delta y square should be equal to delta z square. That is the hypotenuse square equal to sum of the squares of other two sides. So this hypotenuse is the largest side, right? So delta z will be always greater than delta x and delta y. Fine. Yes. Now as we said, z is equal to x plus y. Delta z squared is equal to delta x plus delta y, delta x square delta y square, or delta z is equal to under root delta x whole square plus delta y whole square. Correct? Yeah. Now suppose if z is equal to xy, how will you take this problem? Same, there is no difference. Delta z by z is equal to under root delta x by x whole square plus delta y by y whole square. This is also true for z is equal to x by y. The same result follows. And what about z is equal to x to the power n? That's delta z by z is equal to n times delta x by x. And here you should write the square and here also square. The square will come, everything will come, that is del n square into delta x by x whole square. Now let us see. Suppose I am giving you we have a question something like this. Okay, z is equal to x y to the power minus half. xy to the power minus half. Now I want delta z by z, delta z by z whole square, or yeah, okay, let us write first whole square, then you can write this is 1, so delta x by x whole square plus 1 by 2 times delta y by y whole square. So delta z by z is equal to this whole parameter whole to the power half. Okay, kindly read the question carefully. So time period t is given and delta t. Now, so we want the uncertainty in g. So as we have done in the previous case, let us write g is equal to 4 pi square L divided by t square. So delta g by g whole square is equal to 4 pi square is a constant, so delta L by L whole square into this is squared, so plus 2 times delta t by t whole square. So that is delta g by g is equal to under root delta L by L whole square and 4 times delta t by t whole square. So your option is the option 3. This is another CSIR problem. This is also CSIR. You are asked to find out the uncertainty. Now let us read the question carefully. The measurement of viscous drag force experienced by a spherical particle, that means a spherical particle is here, it is falling down. Okay, particle is proportional to, and the force experienced when it falls down, air is going upward, air, so F is upward because velocity is downward. Okay, there are only very few velocities or forces which acts against the velocity, that is only drag force or viscous force. Viscous force is the only force that drags the particle backward. Okay, yeah, that means F is proportional to V. This is the idea. Okay, now coming back to the question, and this force F is proportional to volume. It is not V here, it is volume. This is V is the volume here, V to the power 1 by 3. Now V is the volume of the particle. If V is measured to be 30 millimeter cube with uncertainties delta V is equal to 2.7 millimeter cube, find the relative percentage uncertainty of force. Nothing, they are asking delta F by F, relative percentage uncertainty. Now immediately when you get the question, write force as a function of V, V to the power 1 by 3. So F, delta F by F, if you want write whole square also, will be equal to 1 by 3 times delta V by V whole square. Please remember it is including 1 by 3. So that's equal to 1 by 9 delta V by V whole square. So uncertainties in delta V is given as okay. So here you need not worry about this square because there is only one variable. So delta F by F will be equal to 1 by 3 delta V by V. So 1 by 3, what is delta V? 2.7. What is V? 30. Since both are in millimeter cube, you need not worry about the unit also. So that is 0.9 by 30. So that is 0.3 by 10, which means 3%. Option is option A. This is another CSI app problem. Let's see. Resistance of a resistor is measured by passing current through it and measuring the voltage drop and current passing through the ammeter. The voltmeter and the ammeter have the uncertainties 3% and 4% respectively. Find the uncertainty in resistance and power. Okay, now resistance is equal to R is equal to V by I. This is from Ohm's law. Then what we can write? So let's write the uncertainties. Delta R by R is equal to under root delta V by V whole square plus delta I by I whole square. In terms of percentage it is written, so we need not worry. This is under root, there is delta V, there is a 3 square plus ammeter 4 square, so that's equal to under root 25, which is nothing but 5%. Now this is the uncertainty in resistance. Now what is the power? Power is equal to VI. Power is VI. Now what is delta P by P? The same formula can be applied. Delta V by V whole square plus delta I by I. See, please make a note that even though the formula changes, there is no change in, see, P is equal to VI and R is equal to V by I, but the change, the uncertainty formula doesn't change. That is equal to root of 25, again 5%. Now here is a simple work for you, that is what you can do is, if I write power is equal to I square R, that is I the current and R the resistance. Instead of VI, I am writing power is equal to I square R. Then what will be the change in or uncertainty in power? Delta P by P. Please find out.